Chapter 1, Rate of Reaction, Class Life Sciences. Part 3, Graphical Study. At the end of this session, students should be able to determine graphically the average and instantaneous rate of formation of a product and of disappearance of a reactant. Explain graphically the variation of the rate with time. (3.1) Kinetic curve. Curve representing the variation in the concentration of a product. This is the axis of abscissa and the axis of concentration, ordinate, and this is the concentration of product at end of the reaction at infinity. The curve is ascending. This is the shape of the curve. The curve concentration product equal Ft is ascending. It shows that concentration product formed increases rapidly at the beginning. Then at the beginning it increases rapidly. Then slowly as time increases and it tends to a maximal value concentration of product at infinity. At the end of the reaction, it reaches the maximum value, which is the concentration product at infinity. Application 2. Plot the curve representing concentration of I2 equal Ft based on table 2. Using the scale in abscissa 1 cm for 2 minutes, in ordinate 1 cm for 1 millimole. Solution of application 2. Then in abscissa the time in minute and in ordinate concentration in millimole per liter. The initial point 0, 0 at 3 minutes, then 6 minutes, and so on. This is the curve till the instant t equal 1.7. It is ascending. Now, curve representing the variation in the concentration of a reactant with time. The curve is descending, has a minimum limit, which is the concentration of reactant at infinity. It starts from the initial concentration, of reactant at t equals 0. The curve concentration of reactant is descending. It shows that concentration of reactant decreases rapidly at the beginning, then slowly as time increases and tends to 0. It completes till 0 if the reactant is limiting, and tends to a minimum limit, which is the concentration of reactant left at end of the reaction if the reactant is in excess. Application 3. Plot the curve representing H2O2 equal Ft. Use as scale in abscissa 1 cm for 2 minutes, in ordinate 1 cm for 2 millimole. Solution. In abscissa time in minute, in ordinate concentration of H2O2 in millimole per liter. the initial point, then it decreases till the end at t equal 27. The last point, not the end time, the last point is at t equal 27. Now, C2, graphical determination of the rate. C21, average rate of formation of a product. Definition: average rate of formation of product between T1 and T2 equal delta concentration product over delta T, or delta N product over delta T according to the function, to the studied function. If concentration equal Ft, then delta concentration over delta T. If number of mole equal Ft, then delta N over delta T. This is the curve representing the variation of the product with time. Graphically, it is the slope of the secant on the curve concentration product equal Ft, or number of mole product equal Ft at points of axis at T1 and T2. Then this is T1. We determine on the curve the point of abscissa T1, the point on the curve, and T2, we determine the point on the curve of abscissa T2. We draw the secant passing through these 2 points. We determine the concentration at the end. The rate becomes variation in concentration, delta concentration of product, over variation of time, delta T. That means concentration 2 minus concentration 1 over T2 minus T1. Application 4. Determine the rate of formation of I2 between the 2 instants 6 minutes and 18 minutes based on table 2. Solution: we write the definition of the rate of average rate of I2 between 6 and 18 equal delta concentration I2 over delta T. Graphically, it is the slope of the secant on the curve concentration I2 equal Ft at points of axis 6 and 18. On the graph, we determine the point of abscissa 6 minutes and 18 minutes. We draw the secant, then we determine the coordinate for each point. For first point 6, 7.15, and second point 18, 13.3. Then average rate of I2 between 6 and 18 equal concentration 2, 13.3, minus concentration 1, 7.15, over T2, 18, minus T1, 6, equals 0.5 millimole per liter per minute. Now, of disappearance of a reactant. Definition: average rate of disappearance of reactant between T1 and T2 equal minus delta concentration reactant over delta T, or minus delta N reactant over delta T. Graphically, it is the negative slope of the tangent on the curve concentration reactant equal Ft, or number of mole reactant equal Ft at the points of abscissa T1 and T2. On the graph, we determine the point of abscissa T1 and the point of abscissa T2. Then we draw the secant passing through these 2 points, and we determine the concentration for each point, and the average rate is minus delta concentration over delta T. That means minus concentration 2 minus concentration 1 over T2 minus T1. Application 5. determine the rate of disappearance of H2O2 between the two instants, 6 and 18 minutes. We write the definition equal minus delta concentration H2O2 over delta T. Graphically, it is the negative slope of the tangent of the secant on the curve H2O2 equal Ft at points of abscissa 6 and 18 minutes. On the graph, we determine the points. We draw a secant on the curve passing through the points 6 and 18, and we determine the coordinate of these 2 points. First point 6, 13.65, and second point 18, 7.6. Then average rate equal minus concentration 2, 7.6 minus concentration 1, 13.65 over T2, 18 minus T1, 6 equals 0.5 millimole per liter per minute. Now, instantaneous rate, first of formation of product. Definition, rate of product at instant T equal d concentration product over dt or dn over dt. Graphically, it is the slope of the tangent on the curve concentration product equal Ft or number of mole product equal Ft at point of abscissa T. This is the curve, and we determine the point on the curve of abscissa T. We draw the tangent on this curve at this point. We take 2 points on this tangent. We determine the coordinate of this point and another point of T2 and concentration 2, and we apply rate at instant T is delta concentration over delta T, the slope of the tangent. Application, determine the rate of formation of I2 at the instant T equal 12 minutes. Ni2 12 minutes equal d concentration I2 over dt. This is the definition. Graphically, it is the slope of the tangent on the curve concentration I2 equal Fp at the point of abscissa 12 minutes. On the graph, we determine the point of abscissa 12 minutes. This is the point. We draw a tangent on the curve at this point, and we take 2 points on the graph, on the curve, on this tangent. If these 2 points are the taking point, the point at which we should determine the rate, which is given in table, the coordinate of this point are given in the table, and the second point is the intersection between the tangent and the axis of ordinate of abscissa T equals 0 and concentration equals 5.5. Then rate of I2 at 12 minutes equal concentration 2 11.1 minus concentration 1 5.5 over T2 12 minus T1 equals 0 equals 0.46 millimole per liter. Now of disappearance of a reactant. Definition, rate of reactant at instant T equal minus d concentration over dt or minus dn over dt. Graphically, it is the negative slope of the tangent on the curve concentration reactant equal Ft or number of mole reactant equal Ft at point of abscissa T. On the graph, we determine the point of abscissa T. We draw the tangent on the curve at this point. We take 2 points on the curve. We identify the coordinate of each point. Then rate equal minus d concentration 2 minus concentration 1 over T2 minus T1. Application 7. Determine the rate of disappearance of H2O2 at the instant T equal 12 minutes based on the table 2. Solution, rate definition equal minus the concentration H2O2 over the graphically it is the negative slope of the tangent on the curve concentration H2O2 equal Ft at point of abscissa t equal 12 minutes. This is the curve. We identify the point of abscissa t equal 12 minutes on the curve. We draw using a ruler the tangent on this curve at this point, and we take 2 points. First point is the point at which we should determine the rate of coordinate 12 minutes 9.8 millimole per liter, and the second point is the intersection between this tangent and the axis of ordinate of abscissa t equals 0 and ordinate 15.2 millimole per liter. Now average rate instantaneous rate equal minus concentration 2 9.8 minus concentration 1 15.2 over T2 12 minus T1 0 equals 0.45 millimole per liter per minute. Now initial rate. The initial rate is the rate at the beginning of the reaction, which means at instant t equals 0. First of formation of a product. Definition: rate R0 is the initial rate of product equal d concentration over dt or dN over d. It is an instantaneous rate, but at instant t equals 0. Graphically, it is the slope of the tangent on the curve concentration product equal Ft or number of mole product equal Ft at point of abscissa t equals 0. The same, we draw the tangent, but now at the origin at t equals 0, we draw the tangent. We take 2 points on the tangent. First point is the origin. We take the origin, which is 0, 0, 0, 0, and a point of concentration T1 and of time T1 and concentration P1. We calculate the slope of this tangent using these 2 points. Then the initial rate equal concentration 1 minus 0 over T1 minus 0. Application 8. Determine the initial rate of formation of I2. We write the solution, we write the definition. Initial rate of I2 equal d concentration I2 over dt. Graphically, it is the slope of the tangent on the curve concentration I2 equal Ft at the point of abscissa t equals 0. On the graph, we draw the tangent at this point on the curve using the ruler, and we take 2 points, the first point 0, 0, and another point, for example this point of coordinate 6 minutes and 14, then the initial rate equal 14 minus 0 over 6 minus 0 equal 2.33 millimole per liter per minute. Now, of disappearance of reactant, definition equal minus the concentration reactant over dt or minus dN over dt. Graphically, it is the negative slope of the tangent on the curve concentration reactant equal Ft at the, or number of mole reactant equal Ft at the point of abscissa t equal 0. On the graph, we draw the tangent on the curve at point of abscissa t equals 0. This is the initial point. Then we take the initial point of concentration 0, initial concentration 0, and another point of concentration, this point of abscissa T1 and ordinate concentration 1. The rate becomes minus concentration 1 minus concentration 0 over T1 minus 0. Application 9. Determine the initial rate of disappearance of H2O2 based on the table 2. Definition: initial rate of H2O2 equal minus D concentration. Minus D concentration H2O2 over dt. Graphically, it is the negative slope of the tangent on the curve concentration H2O2 equal Ft at point of abscissa T equals 0. On the graph, we draw the tangent at T equals 0, and we take the 2 points, the initial point 0, 20.9, the initial concentration of H2O2, and another point we take this point of coordinate 6 and 6. So then the initial rate becomes minus concentration 2 minus concentration 1 over T2 minus T1 equal 2.48 millimole per liter. Now, variation of the rate with time. We have calculated the initial rate of I2 equal 2.33 millimole per liter per minute, and the rate at T equal 12 minutes equals 0.46 millimole per liter. By comparing these two rates, we deduce that R0 I2 bigger than R I2 at 12 minutes. The same, we have calculated the initial rate of H2O2 equal 2.48 millimole per liter per minute, and the same rate but at T equal 12 minutes equals 0.45 millimole per liter per minute. By comparing these two rates, we can deduce that initial rate of H2O2 bigger than rate of H2O2 at 12 minutes. What can we conclude? We can conclude that the rate of formation of a product or of disappearance of a reactant decreases with time. Then, if we compare the rate of a product at 5 minutes and a rate of the same product at 20 minutes, for example, sure, when T is less, the rate is bigger because the rate decreases with time. How can we explain graphically, without calculation, this variation in rate? First, case of curve representing the variation of product versus time. This is the curve. We trace 2 or 3 tangents on the curve. First tangent at the beginning, in the middle, and near the end of the curve. We trace 2 or 3 tangents. The rate of formation, by definition, of a product graphically is equal to the slope of the tangent on the curve concentration product of equal Ft. The rate at this point is the slope of this tangent. The rate at this point is the slope of this tangent. The rate at this point is the slope of this tangent. According to the graph, the slope of the tangent on the curve is maximum at T equals 0. At the beginning is the maximum slope of tangent. Then the slope of the tangent decreases as the tangent nears to horizontal line. Then it decreases with time. Since the slope of the tangent is equal to the rate, then we can deduce that the rate of formation of product is maximum at T equals 0, then it decreases with time till it becomes 0 at the end of the reaction. Now, case of curve representing the variation of reactants versus time. This is a curve. First, we trace 2 or 3 tangents on the curve at the beginning, in the middle, and near the end. Definition graphically, the rate of disappearance of reactant is equal to the negative slope of the tangent on the curve, concentration reactant equal Ft, or number of reactant equal Ft. According to the graph, the negative slope is maximum at T equals 0, then it decreases with time. Therefore, since the rate equal negative slope of the tangent, then the rate of disappearance of reactant is maximum at t equals 0, then it decreases with time till becomes 0 at the end of the reaction. This is the end of part 3 graphical